or object from which the universe started or came into existence, but as a period in the early universe where the universe was very hot, very dense, and expanding rapidly. So the Big Bang is not what happened at t equals 0, it's everything that happened after that. Inflation is thought to have occurred from 10 to the negative 36 to about 10 to the negative 33 seconds. Where did the energy come from to cause this rapid expansion? This problem has not been solved. Cosmic inflation is a process that destroys any information about what came before it. The theory of the Standard Model of cosmology is really only well understood starting at about 10 to the negative 12 seconds because the universe at this point had energies that can be approximately replicated in current particle accelerators. Prior to this time frame, we can only speculate. So anything that we talk about prior to this is largely speculation. We can turn the clock scientifically almost all the way back, but not quite. We don't know much about what happened during the period after inflation, from about 10 to the negative 33 seconds to 10 to the negative 12 seconds. In terms of the forces, gravity is thought to have separated from the unified force shortly after the Planck epoch at 10 to the negative 43 seconds, and later the strong force is thought to have separated at around the time of inflation, 10 to the negative 32 seconds. But from 10 to the negative 32 seconds to 10 to the negative 12 seconds, the electromagnetic and weak forces were still united as the electroweak force. And at this point, the laws of the Standard Model of particle physics tells us the universe probably consisted of quarks and gluons existing together in a quark-gluon plasma, along with some other fundamental particles. But importantly, at this point, all these fundamental particles were massless because the Higgs field was massless at this point. In other words, it had not gained a non-zero potential that allows fundamental particles to gain mass by interacting with it. Where these initial massless fundamental particles came from is still not known. It's possible they somehow condensed from the energies present at the Big Bang, or there might have been an initial scalar field similar to the Higgs field called the inflation field, which consisted of inflatants that decayed to the fundamental particles we see today. As time ticks slightly forward to about 10 to the negative 11 seconds, and the temperature of this hot universe falls a bit further to about 10 to the 15 or 1 quadrillion Kelvin, the lower temperature and energies leads to something called electroweak symmetry breaking at the beginning of the quark epoch. What happens at this stage is that the electromagnetic and weak forces become distinct and separate forces. This leads to the Higgs field gaining a non-zero potential, which looks like a Mexican hat called a sombrero. This means that the fundamental particles that now interact with the Higgs field